Hey, Algebra 2 friends, we're in Chapter 4, Section 5, and we're going to talk about determinants. Here's our vocabulary. The first word we should probably be aware of is what a determinant is. Now, when you have a certain type of matrix, a square matrix or an n by n matrix, where the number of rows and number of columns agree, so if I had something like 1, 2, 3, 4, 5, 6, 7, 8, 9, this matrix would have a determinant and the way or a number that's associated with it. I might write it as this, DET, and then the matrix, or I just might choose straight lines with all the numbers or all the elements of the matrix written right in between those two lines. These two symbols refer to the determinant. And the question about what a determinant is or how you calculate that number we'll get into, but it really is a number associated with a n by n or a square matrix. The second order determinant is a determinant of a 2 by 2 matrix. So if we're talking about A, B, C, D in this case, the determinant, and I can tell you how to get this one, it's not too hard. The determinant would be determined by multiplying down A times B and subtracting up C times B. So the determinant value would be AD minus CB. A third order determinant would be the determinant of a, you got it, 3 by 3 matrix. You guys with me? A, B, C, D, E, F, G, H, I. So this matrix would be a third determinant, this matrix would have a third determinant, right? Or third order determinant rather. Expansion by minors is a type of way that we can use to find the determinant here. Remember how easy this was to find a second order determinant? To find a third order determinant, it's not that easy, and I'll show you later on. And so we have to do it by a process called expansion by minors. And a minor is when we take a look at, we kind of break down the determinant by looking at certain sections of it. So notice if I cross out that top row and this first column, I get this little matrix here, which is a minor. And I know that sounds crazy, so it's going to make sense when we do it. And so that's what a minor is, kind of a smaller version or a smaller part of our matrix or of our determinant, and we'll use them in a moment. So our first key concept is here, and as we talked about before, the value of a second order determinant is found by calculating the difference product for the diagonals. And sometimes I think about the way I personally make an X. And so I make an X by going down like that, right? If you want to cross something out. So I personally make an X like that. So it really is kind of like X multiplication, where when you do, I don't know, I'm making stuff up, but you guys got it. I'm gonna leave that alone. All right, let's look at the next one. So this example simply has us multiplying or finding the determinant value, the numerical value, and this one's going to be negative 16 minus 30, which is going to give us a negative 46, because I multiply down and then I subtract what I multiply up. Multiply down in this one, I get 14. Multiply up, I get a negative 12, so that's minus a minus 12, which is going to become a plus 12, and that's going to give me 26. Now to get to the fun about multiplying or figuring out what the third order determinant is, when you have a matrix like this, if you take A and multiply it by the determinant, this minor here, and then take B and subtract the product of this value B and this minor here, and then you take C and you do the same thing, but you add it, then you get the third order determinant. Right now you should be saying, what? And so what we'll do is we'll go and we'll look to see how we can get those values. If you notice, let me come back down here real quick. If you notice A, if you cross out the row and the column that A belongs to, right, you'll get the minor EFHI. If you cross out the row and the column that B belongs to, you'll get what's left, DFGI. If you cross out again the row and column that C belongs to, you get D-E-G-H, D-E-G-H. So this is one method of actually doing it. We call it expansion by minors. And so what this image kind of shows us is that very thing. A minor of A would be this piece here. The minor of B sub 1 would be these guys that are left uncovered. And the minor of C sub 1 would be these guys that are left uncovered. And so, and we, the way we do it is we do plus minus plus. So A is positive, B is, we take the opposite or the negative version of B, the opposite version of B, and C we take it as it is. So let's go ahead and handle that here. So our A value would be 2. And if we consider the minor associated with that, it would be 5, 9, negative 4, 0. And to that I'm going to subtract my B value, or the next value, which is 7, and I'm going to cross out the row and column that that 7 belongs to, and I'm going to replace inside here, I'm looking for the determinant with these element values, negative 1, negative 4, 6, and 0. And finally, we're going to add this last one. This is like our C value, where we're adding a negative 3, so we just leave it at negative 3. You guys with me? And then we're going to multiply it by the determinant that we get from this 2 by 2 matrix. And so this is how we're going to calculate the expansion by minors. If you're looking at the signs and you're thinking they look crazy, knowing that this one's supposed to be positive, negative, positive, remember A is whatever it is, B we want the opposite, and C we want exactly as it is. A is a positive 2, B is a positive 7, so we want the opposite, which is negative 7, and C we want it exactly as it is. Okay, so we have some calculating to do. So let's go ahead and calculate these determinants. Remember, 5 times 0 is going to be 0, minus a minus 36 is going to be a positive 36. Again, minus 7 times negative 1 times 0 is 0, minus a 6 times negative 4, that's going to give me a positive 24. Negative 1 times 9 gives me negative 9, minus 6 times 5 is going to give me a negative 30. So negative 9 plus a negative 30 is a negative 39. And now I need to do simple multiplication and subtraction here. 7 times 36 gives me a 72. 2 times 36 gives me a 72. My bad. This times that gives me 8. Carry my 2. 7 times 2, 14, 15, 16, 168 here. And then over here, we're going to multiply these guys, but it's actually going to become positive. So I end up with it, because it's negative times negative. When I'm done, I'm ending up with a 117. And so if I join these guys together, and with a little bit of math calculation, we get that this is 21. So that's the expansion by minors way of doing it. There's another way of doing it called the diagonals. And I know they asked us to do it this way, but you know what? I want to use this example so that we could see that we're going to get the same thing by this other method, okay? So let's change this out. There we go. So I rewrote this from the last example, so we should expect to get the same answer of 21. I'm going to hold the 21 up here in my mind. And now for this method, the first thing you want to do is rewrite the entire matrix, and then write the first and second column again right after. So you'd write 2, negative 1, 6, and 7, 5, and 9. And then what we're going to do is run some diagonals through the whole thing. So I'm going to multiply everything that I diagonalize, it's not a word, down. I am going to leave the sign as it is. And everything that I multiply upward in this diagonal, I'm going to subtract. Let me see if I can make that diagonal a little bit better. There we go. And we should get the same answer. So that's really it. The technique is to rewrite the first and second column right after the original determinant, and then you draw these diagonals and you decide that the process says that when we multiply downward, that's going to, whatever sign you get, that's fine. You're going to add all of these values together plus, and then subtract all of these values together. So here's what I have. 2 times 5 times 0 is going to give me 0. And I'm going to add that to the next product here. 7 times 6 times negative 4. I just chose that order because in my mind it works. 40. So this is going to be 7 times negative 4 times 6. 7 times negative 4 is a negative 28. Times 6 is going to give us 8, carrier 4, 12, 13, 14, 15, 16, negative 12, yeah, negative 168. And then I'm going to get here, when I multiply all of these together, I'm going to get a positive 27, right? Negative times negative is a positive 3, times 9 is a positive 27. And so now I've got to do my subtraction. And when I do my subtraction, I'm multiplying 6 times 5 times negative 3, which gives me 30 times a negative 3, which is negative 90. 9 times negative 4 is a negative 36, times 2 gives me a negative 72. 0 times negative 1 times 7 is going to give me a 0. And so let's see what we can do. If I want to join like terms together, or simplify I should say, I'm going to add these two together and I will get, let me get my pen here, I'm going to get a negative 141. And let's simplify what's going on in parentheses here. I've got a negative 90 and a negative 72. That's going to give me a negative 162. And so this minus minus turns into a plus. So I've got negative 141 plus 162. And so when I add these together, it really is subtraction. Subtracting 62 minus 41, I get 21. The same idea we thought we'd come up with. And before we leave this section, let's look at one kind of neat application that comes out of the use of a determinant. So if we are looking for the area of a triangle that has the following, so if we're looking for the area of a triangle with these vertices here, we can set up this determinant, figure out what the determinant value is, and then multiply by 1/2. So let's use that as our guide for this next problem. So if we have our matrix, our vertices here, we're going to create the determinant matrix. So here, and I like the diagonal method, so I'm going to just put negative 1, 2, 0, 6, 4, and 0 here. And I'm going to go through doing what I know how to do. I'm going to multiply downward, and these are going to keep the sign just as they are. And then when I multiply upward, I'm going to subtract those products away. So I could take the sum of all of them and subtract, just like we did last time. All right, so let's go ahead and look at the blue part, and then we'll subtract out the green part and see what we get. So first things first, these guys multiply to give me a negative 4. These guys multiply to give me 0. These guys also multiply to give me 0. And next, I'm going to deal with this going up portion, 0, 0, right? 0 plus 0, 0 plus 0, plus, let's see what we get here, 1 times 2 times 6 is going to give me a positive 12 here. But then remember, this negative here is taking into account the fact that I'm subtracting all of those. I end up with negative 4 minus 12, which gives me a negative 16. And then, okay, so after we've gotten our negative 16, we are going to multiply that by 1/2, right? So because it was 1/2 times the result that we got here. So 1/2 times negative 16 gives me a negative 8. And you should be thinking, what on earth are we talking about? But if we go, because that's a negative number, and how can you have a negative area? Well, we don't. It said that if we did this thing, the absolute value of A, and I kind of missed that myself, is going to, the absolute value of whatever we get for A, once we get A and we take the absolute value of it, so I guess I could do that. Once we get that, that's going to be our answer. So the area, whoop, whoop, of that triangle here is going to be 8 square units, whatever the units are. All right? I don't know. It wasn't delightful, but it was work, and you can do it. And I wish you luck. Go ahead and try to get the work done. Let me talk to you as soon as you have any questions or concerns. Bye-bye.